Okay, hello all you crazy people out there. My name is Michael. I like wizards and dragons and making games, and let's make some games. So in the last couple of weeks, in the last 2 weeks of this tower defense project, I have been working on some optimization strategies in this game, and I have improved performance decently well on desktop computers, on Windows, specifically on computers with dedicated graphics cards, because I have been able to shift most of the workload from the relatively slow CPU side of things to the much faster GPU side of things, at least when it comes to drawing stuff in the game. And that should be fine. That should allow this game to be playable for most people on most computers. But because I do like myself some Raspberry Pi phrasing, I am going to try to shore up performance a little bit more in this game on the Raspberry Pi in certain ways. So this video is going to be, I think, specific to optimizing for the Raspberry Pi. I'm going to be doing some things for optimizing for the Raspberry Pi that I'm not going to have enabled on Windows. And I'm going to talk about separating different configurations for, like, super low-end hardware or just your main game configuration as well. I've done some tests off recording, and I should be able to at least hit high 40s, low 50s frames per second on this thing, which isn't the 60 frames per second that I want, but it's at least higher than 30. And as long as I can maintain a frame rate higher than 30 on this Raspberry Pi, it should at least be playable. Most of this is going to come in the form of optimizing graphics, optimizing the game's graphics. So that means shaders and stuff, and reducing the amount of pixels and vertices that I have to draw. But there may be other things as well. Alright, with that said, let's jump right in. Okay, so for the first thing that I'm going to do, this isn't going to directly affect performance probably, but it's going to make it look a little bit better. By default, and I could have sworn I already did this in a previous video, but apparently I didn't, because it looks like it's already, it's turned off again. Interpolate colors between pixels, this is on by default in the Linux settings, and it's off in the Windows settings. I think it's off by default in Windows. I don't know why it's on by default in Ubuntu, but that's going to make the edges, the borders between pixels look a little bit less fuzzy. If I were to run the game again, you will see what I mean. It shouldn't really have any significant impact on performance. Maybe it'll boost it from like 13 frames per second on average to like 13 and a half, but it'll make things like the UI look a little bit sharper and a little less fuzzy and that sort of thing. And that's going to be important for, especially important for one of the other things I'm going to be doing later in this video. Okay, see, now the user interface is a lot cleaner and there isn't the little fuzzy border between, like, around the 9 slices and that sort of thing. The world looks more or less the same, but the UI mainly looks better, I think. Okay. You can also set this value through GML, obviously. There's a nice function for that, texture GPU set text filter, but we can hit the global game setting anyway. Next, let's see, I'm going to go and create myself another config besides the default config, and this is where I'm going to start to have behavior diverge between Windows and the Raspberry Pi. And let me just go and click this config editor. Let me create a new one. I'm just going to call it Pi. And this is going to allow me to swap between different settings automatically when I run the game. Specifically, I'm going to be making use of some macros, and some macros that can be overridden by different configs. I've talked about macros and configs a long time ago on video. I will link that video in the card and in the video description. This is going to mean things like using a more simplified shader on the Raspberry Pi compared to on desktop computers, and it's going to mean things like drawing the game at a lower resolution and that sort of thing, and probably changing the target frame rate. Okay, what do I want to do first? Firstly, the shader. The shader that I'm using for drawing the game world is one of the lighting shaders that I wrote and imported as a library into this game way back at the beginning, and I decided to call it Luminous Chickens. If you want to find out more about that, links. It's basically a fancy 3D lighting shader. Well, fancy. It's a simple 3D lighting shader. I've talked about it in previous videos. It supports point lights, spotlights, directional lights, and you can evaluate lights in the vertex shader or the fragment shader. The fragment shader causing things to look a little bit more smooth most of the time, but It's not really needed. It's not really contributing to gameplay. For the most part, the only light that we're really seeing in the game world right now is the only light that we're really using right now in this game is a simple directional light to give the 3D world a little bit of shading so that it doesn't look completely flat. And it doesn't really matter that it's evaluated in the fragment shader because I don't think any of the objects in the world actually use smooth lighting except for maybe like one of the towers or two of the towers. It's sort of got a lot of calculations running inside it. It's fine for Windows, but this is the Raspberry Pi's, I keep saying this, weaker GPU is it's a little bit much. And if I can remove some shader calculations that I don't need to do, we'll be better off. So, to start with, instead of saying, and I wrote this part of the code long before Raspberry Pi support was even like a thing that people were thinking about with GameMaker. If I'd started doing this project like 6 months later, I probably would have thought ahead to this a little bit more. Anyway, when you set the shaders, the function is cluck apply, and this, yes, I like chickens. What do you want? It both sets the shader and it sets a bunch of the shader uniforms at the same time, so that you don't have to worry about that. I'm going to start by creating myself a little config macro that stores the shader that we're using, and it's going to be different on the main config and on the Raspberry Pi config. I think I am actually going to create myself another script that's just like Raspberry Pi macros or something like that. And one of them can be the main shader that we're using. I'm going to call this like shader world or something, and by default that is going to be the fragment shader version of Luminous Chickens. And on the Raspberry Pi, which I can determine by putting the name of the config. Oh wow, that's a reserved constant by GameMaker because it's also the math number, the fancy math number. I might have to change the name of this config. But for the Raspberry Pi, we can do this in the vertex shader. And the vertex shader runs before the fragment shader, and it runs on every vertex that's in the scene. And most of the time, at least in GameMaker, when you run code in the vertex shader, it is going to be, and I'm using big, massive air quotes here, faster than if you were to run the same code in the fragment shader. And the reason for that is not that the vertex shader is actually faster than the fragment shader, but there are fewer vertices for it to run on than there are fragments. So if you're filling a million pixels, if you're trying to fill a million pixels in the game window, then the fragment shader is going to run on every one of those pixels, and it's going to run a million times. But if you only are trying to draw 1,000 or 2,000 or so vertices, then the vertex shader is only going to run on every one of those vertices, and it's only going to run 1,000 times or 2,000 times, whatever it happens to be. And that is obviously much less work that the GPU has to do than it would if it was doing the equivalent in the fragment shader. And that's the reason for that.
Hey.
And given that this is a relatively simple GameMaker game, we have more than 1,000 vertices that we're drawing in the scene. We're closer to about, I think, 100,000, but that still should be much less than the number of fragments that it's trying to draw, since each filled triangle can be many, many, many fragments. We can run the equivalent code in the vertex shader. We will have the drawback of not really being able to use smooth lighting, but the shader should have to do much less work. Now, instead of passing the fragment shader version of the lighting shader to the shader apply function, let me just go and replace each and every one of these instances with the macro. And let's see, there's the beginning of the render loop. Obviously, there is the parts of the code where the shader has to get reset if you change it when you're drawing something. Such as if one of the towers is glowing, has got the glowing effect applied to it. And now if I run the game, this isn't going to massively boost performance or anything, but it should. And I'm assuming that it's going to let me use a config named Pi. It should give me a small boost, at least in performance. Because again, the vertex shader has a lot fewer vertices to run on than the fragment shader does. This is the sort of thing where deferred rendering can help. It's not going to help me here, but Let's see. Okay, wow, we're actually pushing 30 just from doing that. I was expecting like low 20s at best, but we're actually pushing 30 FPS here. This is the sort of thing where deferred rendering can help, not on the Raspberry Pi, but on if you're trying to draw a scene that's really intense, like a million triangles, a million vertices or whatever, and you're running on like a 4K screen, a 4K output, and you don't want to have to fill every single one of those triangles. So instead, you'll use a deferred renderer to sort of cut out fragments that you don't really need, that don't contribute to the final view. But anyway, that's a story for another day. I am not going to be running a deferred renderer on the Raspberry Pi. That might make it actually catch fire. Okay, so let me make this another commit. And this is going to be use the vertex shader on the Raspberry Pi. And speaking of the number of pixels that you have to draw being cut down, it would be really nice. And this game is what, 1280 by 720, 1280 like standard HD, I think is what it is. Where's the room? Room underscore test. It is 1366 by 768, so almost. It's a little bit bigger than what I said. That's a little bit big. If we were to scale this down somehow, let's say, what's 768 by 3... I can't do that math in my head. What's 768 divided by 2? Windows calculator. 768 divided by 2 is going to be 384. If I were to cut this in half, we would see that the game is also going to perform somewhat better because there are fewer pixels. And wait, stop. The user interface is off the screen. I don't really care about this part of the UI because I'm just interested in the frame rate and how it's going to affect the frame rate. Now we run the game. Alright, if you hear clicking, that's me pushing buttons on my monitor to set the display input to the Raspberry Pi so that I can actually see it in a window that's big enough for me to see, besides the HDMI capture program. So this should also increase the performance of the game somewhat. Obviously, it's not going to look great because the user interface is going to be flying off the screen, and we've actually got a steady 60 here. This is not the end of the story, unfortunately. This isn't going to be like one and done. The game is running at 60 frames per second because we obviously cannot actually play the game like this. The user interface is way too big and it's in the way. And the game window is pretty small anyway. If I were to, can I maximize the game? I cannot maximize the game. Anyway, as you can see, if we can shrink especially the 3D part of the screen that's being drawn, that is going to further reduce the number of pixels that we need to draw. And that is going to further increase performance on this thing. So we're going to, let's say we're going to do a little bit more work on that. Okay, so let me undo the modifications to the screen size right here, and I'm going to leave the full resolution as it was. But what I am going to do is the 3D part of the game does not have to be drawn on a screen on a surface that is 1366 by 768. If I can go into where is the main game code here? If I can go into here, when the game starts with this fancy show debug overlay and all that, I can say surface resize, and I can say the surface that we are going to resize is going to be the application surface. The application surface being the default surface that you draw on in GameMaker when you're drawing stuff in the draw event and you do not have another surface set. The width can be, let me say, what was it before? 768, and the height can be 384. Okay, and this is going to have some effects. It's gonna not, again, it's not gonna look great, but if I move the output on my monitor back to the Raspberry Pi so that I can actually see what it's doing. We're going to have the UI, and the UI is going to be drawn at full scale, but the game itself is going to be drawn at a reduced scale. Okay? Okay, I see, am I drawing the UI in the draw event? Or is that just the draw GUI event? Anyway, the game is being stretched to fill the window, but you can see it's running at a much lower resolution, and the frame rate counter is off the screen because, Alright, the UI has been stretched. That should help. Can't tell exactly how it's performing. If I were to send in a wave, that is not sending in a wave, but if I were to send in a wave and move around a little bit, it looks like it's running at maybe like high 20s or so, I think is what this might be. Maybe it's a little bit better than that. Is 1366 cut in half 768? Because it looks like 683. Alright, I can do math. Anyway, that's a pretty standard size on like laptop screens. I don't know why GameMaker defaulted to it when I started the new project on here, but never mind. The UI. So there is a handy function, and it is called Display Set GUI Maximize. And this is something I have not talked about in video before, but this is just going to tell GameMaker to draw the user interface at a resolution that is the same as the game window, rather than the application surface. And this is going to cause the user interface to not get stretched when I shrink the application surface. You can see that it takes a couple arguments. These are optional arguments. If you don't specify any optional arguments, it'll just be, the scale will just be set to that of the game window. And if I run the game again, okay, the user interface is back. It looks good, but the game is once again being drawn at the half scale. You can see the pixels are bigger. You can see the frame rate is higher. It's gone up to about mid 40s actually, rather than like high 20s like I was guessing. It looks jittery. I don't know if, for the longest time, if you had shown me video that was 60 and 30 frames per second, I would not like be able to pick out which was which. But I don't know, have I finally been looking at 60 frames per second screens for long enough to be able to tell the difference? Because it does look slightly less smooth when I move around. Slightly less smooth. It's not like it'll make gameplay impossible, but I don't know if I'd want to play a first-person shooter like this. Anyway, we can see that this is doing what it's supposed to. It's running better than it was at the beginning of this video. The frame rate is about triple what it was at the beginning of this video on the Raspberry Pi. I consider that a win. There's more. There's more that we can do. Like I said, I was able to, off recording, push this up to a maximum of like 52 FPS. 52 frames per second. And there's still a little bit more that we can do. Alright, let me end that game. First thing to do is make a commit. By the way, before I do that, if you want to, you can also go a step further and say application surface draw enable. Set this to false, and then you can take over drawing the application surface manually wherever you want. And for example, in the draw GUI event, or in the draw GUI method or whatever, you can say draw surface. You'll probably want the stretched version of draw surface. And this will allow you to scale up the surface to an arbitrary size, which will let you fill the entire screen. With the application surface, and it won't be shrunk down or anything. If I were to use the... It gets me every time. There's some combination of keys on my keyboard that I can hit. And it will like jump me to the bottom. It's like page down and shift or something like that. And I keep hitting it by accident. And it's very annoying. Anyway, if you do this, and I'm not going to switch the monitor input to the Raspberry Pi, I'm just going to show the HDMI capture because it'll get the point across. The application surface will just be feeling like a quarter of the screen, which is not really the desired outcome. So if you ever draw the application surface yourself in the draw GUI event, yeah, that's what I mean. Or in the post draw event, which would technically be the more correct way to do it, you probably want the stretched version of the draw surface function so that you can fill the entire screen no matter what size it is. Or you can only fill part of the screen if that's really what you want to go for. I'm just going to draw this here in the draw GUI event. I don't care about being that correct. At least not right now. Anyway, make a commit. Draw the application surface at half size. And again, since I do want this to be a Raspberry Pi configuration, I will go create myself another set of macros. Macro, let's say app surface default width, and that can be the full, I'll just say window get width. Same thing for the height. And on the Raspberry Pi, I am allowed to use a config named Pi, by the way, and it doesn't, GameMaker doesn't try to interpret that as a math number or anything like that. We can cut it in half. So this is going to be 683 by 384. And instead of directly saying set the size of the application surface to this, we will be instead saying set the application surface to the size that is dictated by the config macros. And now I can run the game on the Raspberry Pi, and it's going to be, the 3D part of the world is going to be running at half resolution. And, where are we? Okay, here we go. You can see the pixels are a little bit on the blocky side, and the game is running at mid-40s frames per second. Whereas, let's see, if I were to switch the config back to Windows, and if I were to run the game on Windows, you can use the Raspberry Pi config on Windows if you want, if that would be faster for you to test. But anyway, if I were to run the game on Windows again, we would be seeing that the resolution is where it was before, and we would still be using the fancy fragment shader lighting. Okay, looks good. Looks good. The game is running at a steady 60 on Windows as it was earlier. And this, on that note, this config could also be used for other things that are not the Raspberry Pi. If you really do run into issues running this game on like a laptop that doesn't have a graphics card or something like that, or if I were to decide to try and run this game on a mobile phone or something in the future, and those tend to be a little bit lower end than a desktop computer, or God forbid, the Nintendo Switch. You could drop down the config to the Raspberry Pi config and run the game at lower graphical settings. I may in the future make at least the application surface resolution a setting in the game's menu. If the Raspberry Pi 5 ever comes out with a better graphics card or something like that, a better GPU, and you don't need this particular optimization, and you want to be able to run the game at the like the full resolution in 3D, you can do that. But we'll cross that bridge when we get there. All right, did I make this a commit? I did not. All right, the last thing that I have in mind, well, really the last main thing that I have in mind anyway, is on the surface, on the subject of making the shader simpler. Where is the shader? On the subject of making the shader simpler, I am only really interested in using one light anyway. One light in this world, a directional light, and I can, if I want to, cut down the max lights macro in the shader to 1, because I'm only going to need the 1, and I could cut it down in like the GML side as well so that the shader uniforms match up. But if you're going to do that, you can also really go a step further, because you don't need all of the other stuff that deals with having a having the other light types going with it. There is an if statement in here. There's actually 2 if statements in here. I generally tell people not to worry about if statements in their shaders, but if you can get rid of them, it's not a bad idea. Particularly on something like the Raspberry Pi, and if you've only got one light that you're ever going to evaluate, and you know that it's going to be a directional light, there's no reason to have the if statement, so we really can just remove this from the shader entirely. I am actually not going to do this here. I'm going to create myself another shader. Let's see, can I Control-Z correctly? There we go. I am going to create myself Control-D, duplicate, I'm going to call this like Vertex Basic or something like that. And I'm going to actually make this the shader that is running in the Raspberry Pi config. And let's see, what do I want? I can just separate the directional lighting part of the code, so that the point lights and all that aren't there. I can set the max lights to 1. This is a compile time constant. In fact, I think I can go a step further, because... Okay, no, never mind. This is a compile time constant. This isn't going to be any like thing that can be optimized. But max lights is going to be 1. The size of the light data array is going to be 1 times 3, so that's going to be a uniform of 3 vector 4s, and that's going to contain the color of the light, the direction of the light, and it's going to have a vector 4 in it that's not really used, and I don't really mind that because it's just a single vector 4. The bulk of the performance optimization is going to come from the other things that we're going to be doing. These are just some defines, some preprocessor defines. Those are fine. It doesn't matter. Those can stay there. And if we're going to, I think if I were to like pass all the extra shader uniforms to the shader, when it only expects like a single light, it would break. Let me just test this on Windows because that's going to be faster. I think the shader will reject that. I think this may cause an error. Otherwise, oh no, okay, so it's fine. At least on Windows, but I'm gonna do it anyway just because it makes me feel good. The number of lights that we're going to be passing to the shader, max lights. I'm going to put this in the Raspberry Pi config, and that's going to be 1. And we're only going to be dealing with a single directional light when we're doing this on the Raspberry Pi, and that should, if I can switch my target to Ubuntu, that should give me a couple extra FPS because it's once again less work that the shader has to do. It's evaluating 1 fewer light, and it is not evaluating an if statement. And these are gains that will add up over time. And on the Raspberry Pi, it actually rejects it. Array too large for shader. Why is that? I thought I made this the same size. I did set the. All right, that's interesting. What's the size of the array? I guess I can debug that. So it's interesting that this is a behavior that's different on Windows than on OpenGL. On Windows, the GLSL ES shaders will be transpiled into HLSL, which is for Microsoft's DirectX, but on Ubuntu it'll basically just stay as OpenGL. The config is pi. I did spell the word pi correctly, and what was the error message? Oh god, I've already forgotten the error message. It was like the uniform array is too large for the shader or something like that. Where is cluck apply? I can look at this. It was light data. It was it's basically an array of 1, or an array of 3 anyway, and that should be they're vector 4s, so they would be 4 values times an array of 3 is going to be 12 values, so there should be 12 values in here. In the init function, this is going to be, can I like show message the size of this? And make sure that it's the correct size. Alright. Anyway, what I was getting at before is I suppose Windows is more forgiving when it comes to it. It's 24 for some reason. Why is that? The config macro is not being applied. Does the config macro have to be set in the same? Yes, I know. Does the config macro have to be set in the same part of the code that the as it's defined the first time? And can it not be overridden elsewhere? I guess so. I did not know that. Admittedly, I don't usually try to override macros in parts of the code other than where they're first defined, but alright. Anyway, yes, as I was saying, Windows and HLSL and DirectX being more forgiving than OpenGL. Alright. I guess that's one config that can't be defined in the Raspberry Pi config setting place. That's gonna be a pop-up message, which is supposed to tell me the number of uniforms or something, but I guess it wasn't. It didn't actually show anything. Anyway, I saw high 40s. I saw 50 briefly, FPS, and that's Are we gonna be able to do that again, or are we going to be stuck at high 40s? Okay. Doesn't look like it's gonna hit 50 again, but high 40s again. That's better than where we started. It was doing, okay, there it briefly reached 50 again. It was doing about 45 before I did the shader trick. I was actually expecting better, considering that I was cutting down on cutting the number of lights that I have to evaluate in half. But anyway, I say this works. Let's see. One, I can get rid of the show message here because I really don't need it anymore, now that I know the values are correct. Two, I can make a commit. So wait a minute, did I actually... Okay, I did. I did set this to the smaller, to the simpler shader. Okay, with that in mind, there is a little bit more that can be done still. One is in the fragment shader, we still have code running that calculates fog on every pixel. We don't really need that. I'm not using fog in this game, at least not right now. Should I leave that there? I'll leave the code there. I won't, I'll comment it out just in case I want to use it for some reason or another. Maybe make a spooky themes map or something. This is alpha testing. This is discarding pixels that are transparent. I have a hard time saying I need this. Actually, for now I do. For the foes, this is needed because those are just right now sprites, and they do have transparent pixels in them. If I were to comment this out, I will probably delete it later. That'll increase performance a little bit as well, but you will see things like transparent pixels overlapping things when it comes to drawing the enemies, which are just right now sprites. I'll run that to show you what it's going to look like. Let's see. Alpha testing is, like, more expensive than I really would like it to be, unfortunately. If every pixel has... If you don't have any transparent pixels in the world, or if you have a minimal number of transparent pixels in the world anyway, like you would often see in like professional AAA games, you would generally not see transparency except for some specific situations like soft particles or windows or something like that. You can get away with not alpha testing. I guess I can send in a wave, and that will give you a nice performance boost. But if these guys were to overlap in just the right way, you would see that they are like sort of cutting each other out, which is maybe not what you really want. If I can, yeah, there you go. You can see some of the pill bugs are causing each other to not be drawn fully. So that second pill bug, woodlouse, whatever, is sort of overlapping. Doesn't look great. Probably what I'm probably gonna do later in this game is find or create or, for all I know, commission actual 3D models for these things, and that will increase the number of vertices slightly, but it will remove the need to do alpha testing, and it will it'll make them look better, because right now, honestly, they look really bad. But that's something for later, I think. So we can leave that in for now. Let's see, there is a not insignificant part of me that feels like this extra function call is doing a little bit more work than it has to, but I don't think this is really... Like, I can also comment out common fog setup, can't I? Because that's just doing a matrix calculation. And, it's a little bit of floating point math, and it's sending a uniform to the fragment shader, but it's not being used in the fragment shader, so it's okay if we don't do that. I think. Is it going to complain if the uniform isn't set? Should I just remove the uniform? Should I comment out the uniform? Okay, it's still working, and it's not really affecting the frame rate in a meaningful way, but cutting out extra floating point calculations that you don't have to do is never a bad thing. All right, I think that's where I'm gonna leave it. We're hitting a steady 50 frames per second on the Raspberry Pi, which is honestly pretty good in my opinion. Remove fog from the shader. Fog isn't overly expensive to calculate, but if you don't need it, there's no point doing the extra math. There is one more thing to do, and that is so that the frame rate doesn't bounce around, which, in my opinion, has always been more annoying than a frame rate that's just below 60. I'm going to lock the frame rate on the Raspberry Pi, at least for now. So I'll say macro target FPS can be 60 by default, and on the Raspberry Pi, we can make it 30. And when the game is initialized up here, We can say game set speed. This is the new version of what used to be forever in GameMaker, the old room speed. Room speed is not going to affect the frame rate anymore. If you want to change the frame rate of your game, you need game set speed. The value is going to be FPS, FPS target. Target FPS. And the type, you can define frames per second in either milliseconds, so basically frame time, or frames per second. Game speed FPS. We're going with FPS. If we were doing milliseconds, we would be saying 16 on Windows and 33 on the Raspberry Pi, because that is the number of milliseconds per frame. And this should make the frame rate more steady. It's always bothered me in games a lot more if you have the frame rate bouncing between like 40 and 50 than if the frame rate was just a steady 30, or even lower than that, even 24. Doesn't bother me as much if it's steady as a frame rate that's like choppy would be. We can see now, we have a steady 30 frames per second. I need to actually use the correct mouse, the one that's plugged into the Pi and not the one that's plugged into Windows. We can place down towers, and we can play the game. This is gonna work. This is a functional game now on the Raspberry Pi. No performance issues here. That may not have been optimal because these birds are gonna chase instead of sort of hitting their targets head on, which is not usually a preferable tower defense strategy, because that's going to cause them to miss somewhat often, like there. Okay, can I upgrade anything? I cannot. I need more money before I can do that. I can set things on fire, though. I'm gonna set things on fire. I'm gonna end this off here. I'm gonna actually play the game here on the Raspberry Pi. This is, when GameMaker first picked up Raspberry Pi support back in beta last October, in October 2020, and I think it officially came out in November. Maybe a little later than that. Stephen Loney, the 8-Bit Warrior, said, I'm now going to sort of stress test all my games on the Raspberry Pi, because I'm going to assume that if they can run on this thing, it can run on anything. And that's not inaccurate. I'm probably going to pick up a similar philosophy, at least for this game, at least for simpler games. If I'm running something that's actually a little bit more graphically demanding, it's probably not ever going to run on the Raspberry Pi 4. But it's a nice ambition to have. Whoa, you're getting through. Can I not have you all get through? That might be a game over. Anyway, yeah. This runs on the Raspberry Pi. I'm gonna die. The frame buffer is gonna completely spaz out. I don't really want to look at that. All right, game over. Anyway, I think this is a sort of fun sort of task. On Windows, there's obviously the default config, which is the main settings, which are a little bit more demanding. But if I need to build a version of the game that's simpler, if someone wants to run the game on a really old computer on like Windows Vista or something, we can give it a shot. All right, was there anything else? There is the frames per second, which I have not yet committed. Game FPS is set to 30 on the Ras Pi. And again, this is something that may be a toggleable setting later on in the game. This is just going to be the default FPS, the default frame rate. It's going to be 60 or 30, but I may very well make a setting somewhere in a settings menu that allows you to switch between like 30, 60, and I don't know, unlimited if you're one of those people. Just like the resolution. Anyway, I'm gonna stop. My name is Michael. I like wizards, dragons, making games on the Raspberry Pi. If you want the code for this, look in the video description for a link to the GitHub repository if you want to mess around with this. I'm especially right now interested in not only performance, on how this game performs on different pieces of hardware, but also game balance itself. Because I've done a bit of work when it comes to game balance, but I haven't. It's still very, very rough around the edges. There are still some towers that are just sort of overpowered. There are still some that are just sort of underpowered, and I'd like to bridge the gap a little bit. I'd like to make it a little bit more reasonable. There is one more particular optimization that I want to do later, and that's going to be how fast the game loads, because it does take a little while to load right now due to the like vertex buffer shenanigans and the de-screwed reads that I have to do to like read collision information from the vertex buffer. And those are somewhat expensive, and I'd like to make those faster, but that's going to come later because I want to get back to gameplay things. I have a Patreon, so if you want to contribute towards these videos being made, there are links to those in all the usual places. Otherwise, I try to post about 2 game day videos a week, one of these tower defense videos and one tutorials. I hope you all found that interesting, and I will see you all later. Special thanks to Kiara Elizabeth, Connor, David Key, Edward Holt, Emily Koyo, Halo Factory, Posho, Sindra Larson, Tusk, and Zenith for supporting these videos. If you want to see your name in the credits or to hear yourself shouted out at the end, head on over to the Patreon page down in the video description to join the fun.